this video, we are going to tackle about what is atomic absorption spectroscopy. This includes also who is the inventor of AAS and when it was first used. When and why should we use AAS, and lastly, its importance. What is atomic absorption spectroscopy? Spectroscopy is a study of how radiated energy and materials interact. Matter absorbs energy, which will create some sort of change in its state. The atomic part refers to the atom in a material which will absorb radiated energy from a light source. These atoms will each have their own characteristic when it comes to absorbing energy because each element has a unique electronic structure. Therefore, using AAS, you can measure a specific element in a material based on the amount of light absorbed at a defined wavelength, which corresponds to the known characteristic of an element you are testing for. Take note that AAS is also referred to as atomic absorption spectrometry. The difference between spectroscopy and spectrometry is that spectroscopy is the study of how energy and material interact, while spectrometry refers to how you apply this as a measure technique. For practical purposes, it doesn't really make any difference which term you use. But when was atomic absorption spectroscopy first used? The basic principle of light absorption through atoms in the fundamental state was discovered and documented in 1860 by Kirchhoff and Bunsen. The discovery is considered to be the theoretical basis of AAS. However, the actual year of birth of AAS is seen as 1955. In 1955, the modern era of atomic absorption spectroscopy began with the work of Walsh and Alchemade and Millatz. The time since 1955 can be divided into 7-year periods. The first was an induction period 1955 to 1962 when AA received attention from only a very few people. As AAS has developed since the time, with the continuing application of new technology, including automation and computers, it has become an extremely reliable analytical technique. It is fast, sensitive, specific, and user-friendly. Why should we use atomic absorption spectroscopy? AAS provides a high degree of accuracy. Normally, results fall within a range of 0.5% to 5% accuracy, but this may improve further depending on the standards set for testing and analysis. It is a highly sensitive method of analysis. In a given material, it can measure parts per billion of a gram. In applications such as medicine and pharmaceuticals, AAS has helped revolutionize practices detecting things such as trace toxins. But when should we use atomic absorption spectroscopy? Atomic absorption spectroscopy has different laboratory and testing applications in industrial, clinical, and research settings as a crucial component in various processes like quality control, toxicology, and environmental testing. As a method, AAS can analyze the content of certain metals in various materials. Like in environmental testing, it can measure the concentration of various elements in rivers, drinking water, and seawater. In the food and drink industry, it can measure various concentration of elements in wine, beer, and food drinks and test for types of contamination in food. For pharmaceutical companies, AAS can determine the minute quantities of catalyst materials used in the manufacture of drugs and for the other impurities. In mining, AAS can test for the concentration of valuable material before excavation operation. It is also used in agriculture to analyze plants and soil for mineral content. Metals and other substances can have a bad effect on oil and gas, which is why the petrochemical industry uses AAS too. The technique also supports critical testing in the nuclear industry, where there could be potentially hazardous elements in the output of waste and water. And Lastly, why is atomic absorption spectroscopy important? Metals occur naturally in the world around us, and around 3/4 of the Earth's chemical elements are metals. Sometimes metal content in a material is desirable, but metals can also be contaminants. Therefore, measuring for metallic content is a critical part of many different processes. Although atomic absorption spectroscopy has been an established method for analysis of materials for metallic elements for how many years, it remained a benchmark technique. This is because it has a greater sensitivity than other methods with less limitations. For some liquid samples, it can provide direct analysis. It also works accurately with very small sample sizes, making it rapid, efficient, and economical as a testing method. Various industries and sectors are dependent on this form of testing to ensure their products or the materials they are processing are sufficiently free from contamination or contain the right degree of certain metallic element to support their intrinsic value.